Okay, so this week I have problem 41 assigned to me, and pretty much what this problem is that it's giving us a system like this with 4 different positive charges with a mass 0.001 kilograms, and from this we have to find the final velocity it's going to have as they're allowed to move away from each other. I guess they're kind of probably taped down or something, but they can't move, so they're going to have a potential energy. So that's the first thing we need to do, is we need to find this potential energy. Now right here, first step here is the definition of the potential energy for an electric potential. It's going to be a charge times the voltage. So this pretty much breaks down into KQ over R. That's the V. You times that by Q, which is going to be the charge it's acting on. So I mean, this KQ could be the voltage for here, for this charge here, and this could be the Q from this one or this one or this one or any of them. So we pretty much have 2 different relationships in the problem that we're given here. There's a relationship between the charges that are right next to each other, like vertical or horizontal, and then there's a relationship between these 2 charges here that are across from each other. So as we can see, the total potential energy of this whole system is going to be the relationship between all of these charges. So I mean, there's going to be a potential energy right here between these 2, potential energy between these 2, and these 2. So that's 4 potential energies that are going to be the same. So all we really need to do is find one, multiply by 4, and then we'll have all of those relationships there. So if we want to go ahead and start plugging stuff in, K is going to be 9 times 10 to the 9th. All the Q's are the same, they're 10 nanocoulombs, so radius is going to be 1 centimeter here. And since there's 4 of them, we're going to have to times this whole thing by 4 here. 4 times that, and then we'll get the potential energy for that relationship right there. Turns out it's 3.6 times 10 to the negative 4th. Okay. Next relationship we're going to find is this one right here at the diagonals, and there's 2 of those, so just know right now that we're going to have to times this one by 2. So 2 times, and it's going to be pretty similar, except the radius is going to be different. Radius is going to be right there, which I'll just put in this, but it's the same thing. If you carried that out, it'd be this. Times it by 2, solve all that. Oh, I'm sorry, this is going to be in joules right here. And so is this. And this is going to be 1.28 times 10 to the negative 4th joules. So now that we know the total potential energy of this system here, we can go ahead and set that equal to the kinetic energy, and from there we can solve for V. So add these 2 up together, to get our total potential energy. It's going to be 4.87 times 10 to the negative fourth joules. Okay, we could set up our conservation of energies expression here. Kinetic energy plus potential energy initials equals kinetic energy potential energy final. Now in the beginning of this system, our initial potential energy is what we just calculated, but we know that it's not moving, so the initial kinetic energy is going to be 0. And when the question states what is the speed when they're very far apart, this is assuming that there's no more potential energy left, so our potential energy is going to be 0. So pretty much what we're left with is our initial potential energy is going to equal our final kinetic energy. So we can go ahead and dump the number that we found for our initial potential energy right here. Joules. That's going to equal 1 over 2. The M is the mass of the 4 balls. It's 0.001 kilograms. And V final, that's what we're trying to solve for. Finally, one thing that's kind of different about this is that this here is gonna, if we solved it for V as it is right now, it's gonna solve for the velocity of one of these particles. This is the kinetic energy of one of these balls here. But we didn't find, but if we did that, then this expression wouldn't make sense. We solved the potential energy initial for the 4 balls, so we gotta solve the kinetic energy also for 4. So this whole thing, we could put a bracket around, times it by 4, and then after you do all the algebra, divide the 4 over, multiply by 2, divide by 0.001, put a square root over it. Our final velocity is going to equal 0.49 meters per second.